Do you feel ignorant because you don't know numbers? You don't know which one go which way, and they got all these marks and things on them? I know, honey, it's hard, but there is a solution. Fort Bend Tutoring. And now here go Mr. Whit. Explain math to us, Mr. Whit.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, and today's lesson is going to be about inequalities. That's right, solving and graphing inequalities on a number line. Yeah, on a number line. So before us, we have different inequalities. Yeah, we have the less than symbol. Yeah, we have the greater than symbol. There you go, right there. We have that less than or equal to symbol, and we also have the greater than or equal to symbol. We sure do. So when you have a less than symbol or a greater than symbol on a number line, you're going to represent the value with an open circle, or in some classes you'll use parentheses. So depending on what level of mathematics you are, you'll use either an open circle or parentheses. Yep. When it comes to your less than or equal to, or your greater than or equal to symbols that are used on the number line, you'll use either a closed circle or brackets. All right, and for this lesson, I'm going to be showing you how to use both the open and closed circles as well as parentheses and brackets in this one lesson today. So let's go ahead and get things started, shall we? In problem number 1, I have 4x minus 18 is less than 2. So you want to isolate your variable x and isolate it only on the left side, okay? So that's pretty important, ladies and gentlemen. It's not that you have to, but it's a preference, a strong advisement for me to always solve your variable on the left side of the inequality, especially if you have to end up graphing it, okay? So I will only be solving for the variable on the left-hand side during these exercises that I show you in today's lesson. So I'm going to isolate the variable like it's an equation. So I'm adding 18 to both sides of the inequality here. My 18s will cancel out. I'm bringing down 4x, which is less than 20, and then I'll need to divide both sides by 4. All right, so the 4's will cancel out. I'll end up with x being less than 20 divided by 4, which is 5. All right, and this is my solution. Yep, just like this. However, this is only one of the many different ways that you can represent this solution for your inequality. And I'm going to show you those different ways now. The first way to represent this answer, besides just having your solution x is less than 5, is to actually graph it on a number line. So on your number line, okay, depending on your instructor, you may need to have many different texts, but for today's lesson, the most important number on this number line is the number we just solved for, the 5. So I'm going to put 5 on my number line here, just like that. All right, so once we have our 5 on our number line showing here, we're going to represent that with an open circle. All right, so using an open or a closed circle, you'll show that that open circle is at 5, which means that you're not including 5, but everything less than 5. So that's why we'll need to shade to the left of 5. So you're showing the reader here that everything to the left of 5 is a solution, but not 5 itself, which is why we use an open circle. So that's what happens when you use an open circle on your number line, but let's see what happens if you had to use parentheses. So I still will show that I have 5 on my number line, and I'm going to represent that 5 with parentheses. Since I know I'll end up shading to the left of 5 because my solution involves numbers that are less than 5, which are always to the left of 5, I'm going to shade to the left. And that's why I have my parentheses pointing to the left as well. All right, so keep in mind that the reason why I want you to solve for your variable on the left-hand side is because it will always point to the way you need to shade. So for instance, my less than symbol is pointing to the left, and notice that on my graph, my shading is to the left of the number that we're representing here. And that's it. So there you have the graph using an open circle, and there you have the graph using parentheses. Remember, parentheses are only used if you have a less than or a greater than inequality symbol, and open circles are only used for that same reason, because the inequality has a less than or a greater than symbol. All right, so thus far, I've shown you the solution, I've shown you the graph, and now I'm going to show you 2 other forms to represent your answer. The next way I'm going to show you is called interval notation. That's right, interval notation. And we can basically use our graph to help us do that. To the extreme left of your number line, we have this arrow that points to negative infinity. To the extreme right, we have positive infinity. Interval notation always shows your solutions from the lowest value to the highest value. The lowest value of my solution is going to be negative infinity. You represent infinities always with parentheses every single time. So I'm going to have parentheses negative infinity. Then I'll show that we're approaching 5, but not including 5, by using parentheses as well. Okay, so the parentheses and interval notation tell the reader that you're approaching that value, not that it equals to that value. So our solution is in the range of negative infinity to 5, ladies and gentlemen, and that's the interval notation of our inequality. That's it. Next, I'll show you the final way that you can represent your solution when dealing with inequalities, and that is using a notation called set builder notation. That's right, set builder notation. Some teachers reduce that to just set notation, but the proper name for it is set builder notation. And basically it's just fancy dressing on your solution. So recognize that our solution is just x is less than 5, right? Well, set builder notation says that you're going to use braces. So you'll start off with a brace, and I really can't draw braces, but that'll do for today. It's going to be x is such that, the vertical bar means is such that in mathematics, then your solution x is less than 5, and then you'll finish with a brace. Notice how that brace is jacked up, but that's the best you're going to get from me. So here, it's just fancy window dressing on the solution. Yeah, it just simply means that x is such that x is less than 5. So all you do is add the brace, add the variable, and that vertical bar there, and you have what is called set builder notation. Set builder notation. So these are 4 ways that your answer can be represented. Yeah, 4 different ways. Well, 5 if you include the fact that I showed you 2 ways to graph it. So you have your solution, which is x is less than 5, and you have your line graphs of your solution using an open circle, or if you're in a higher level mathematics class, you're using parentheses. And I also am showing you interval notation as well as the set builder notation for problem number 1. All right, let's keep this thing going now. Let's keep it going. That was problem number 1. I have more to show you. All right, in problem number 2, we have x plus 15 is greater than or equal to 12. So in isolating your variable, I'm going to subtract 15 to both sides of the inequality here. This gives me x is greater than or equal to negative 3, and that's my solution. That's it. Solution done. Done and done. Let's go ahead and see about the line graph. How do I represent this inequality using a line graph? Well, for starters, all I need to show is that I'll begin with negative 3 on my line. So I'm going to use a closed circle this time, because anytime I have a greater than or equal to symbol or a less than or equal to symbol, I use a closed circle here. All right, so there's my closed circle at negative 3. The closed circle means that you're including the value of negative 3 within your solution. Then notice how we've isolated a variable on the left-hand side, but the inequality symbol itself is pointing to the right. Exactly, which means I need to shade to the right to show where the remainder of my solution is going to be. That's right. So things are greater than or equal to negative 3, and this is the line graph of that inequality. All right, that's that one. All right, so this time I'm going to show you this line graph using brackets. We're not using parentheses this time because it's or equal to. Remember, anytime it's less than or equal to or greater than or equal to, you're going to use a bracket instead of parentheses in your higher level math classes. So let me change my ink color to green. And because I know I need to shade to the right, I'm going to point that bracket facing to the right. And then I shade to the right. That's it. So this is going to be my line graph for the inequality x is greater than or equal to negative 3. Just like that. All right. So next I'm going to represent my solution, x is greater than or equal to negative 3, in interval notation. And normally your interval notation is going to be a direct translation of your line graph, especially if you're using brackets and parentheses. So remember, interval notation starts with the lowest number to the highest number. So with this particular problem, I start with negative 3. So I'm going to use a bracket, and then I have my negative 3, and then the highest value. Notice that my shading is to the extreme right, is going to be positive infinity. All right. And remember, you're always going to express infinities with parentheses. Never use brackets with infinities, whether it's negative infinity or positive infinity for any reason. All right. So that's the answer in interval notation. Okay, great. Next, we want to look at set builder notation. Remember, we started out with x is greater than or equal to negative 3 as our solution. So the set builder notation is just a fancy way of writing your solution. So I'll have x is such that x is greater than or equal to negative 3, and that's it. That's it. And these are really good braces for me because my braces usually suck bad. Yeah, normally they do. All right, this is a good day for braces for me. All right, so that means that we're done with number 2. And so now we're on to the next problem. Are you ready? Good. Well, we have 26 minus 3x is greater than negative 1. Once again, I want to isolate my variable on the left-hand side because it helps when it comes time for graphing and just makes the process consistent for me. So I'm going to start by subtracting 26 to both sides of my inequality here, just like so. I'll be bringing down my negative 3x, which is going to be greater than negative 27. The next step is to divide both sides by negative 3. Anytime we divide or multiply by a negative value when you're dealing with an inequality, you must always change the direction of the inequality sign. The reason for that is because the negative sign itself means to find the opposite. So we are not finding the opposite unless we're also finding the opposite of our inequality symbol. So that means we need to change the direction of the sign, bottom line. So I'll be dividing both sides by negative 3 now, and once again, because I'm dividing by a negative value, I'll need to also change the direction of my inequality symbol. So it started out as a greater than symbol, but now after dividing by a negative, finding the opposite, it becomes a less than symbol. So this is x is less than 9. Yeah. And that's the answer. It's over now. That's the answer. Now let's get these line graphs in order. So to graph this, I'm going to need a 9. I'm going to write it twice because I'm going to show you 2 different ways. And let's go ahead and change the ink color. So here we are. So my solution is x is less than 9. So will I use an open circle or a closed circle? What did you say? Speak a little louder. Okay, there you go. I need an open circle at 9. That's exactly right. Notice that my inequality symbol is pointing to the left, which means I'm going to shade to the left. And that's it. That's it. Now, if I were to use parentheses or brackets, I'll need parentheses because I use parentheses when I have a less than or greater than symbol. So I'm going to point it to the left, knowing that I need to shade to the left itself. So here we are, shading to the left, and there's your line graph if you were to use parentheses. All right, the next thing I want to show you is your interval notation for this. Interval notation, remember we're starting from the lowest value to the highest. My lowest value would be negative infinity. All right, and then the highest value is 9. Remember, I'm approaching 9, so therefore I'll use parentheses. And that's it. That's the interval notation for that. All right, one last notation to share with you, and that is set builder notation. Remember, my solution is x is less than 9. So here's the set builder notation representation of that. I'm going to start off with a brace. It's going to be x is such that x is less than 9. And then I'll close that brace there. And that's it. That's my set builder notation. All right. So depending on the different ways your teacher, your instructor, your class wants you to represent your linear inequality, you have the solution, the line graph, interval notation, and set builder notation at the ready. All right. Let's move on to the next example, shall we? Here we are. We have problem number 4. And in problem number 4, I have negative 15 plus 4x is less than or equal to negative 2 times the quantity of x minus 5 plus 8. All right. Well, this particular problem has my favorite property in it. That's right. I get to get my arrows popping because I love the distributive property, just because I get to draw arrows. For real, that's the only reason why. So I'm going to bring down negative 15 plus 4x, which is less than or equal to negative 2x plus 10 plus 8. All right. I don't like the 8 either. All right, so I'm going to fix the 8. That's a much better 8. Don't you agree? So after I distribute, I'm going to now combine my like terms. All right, so on the right side here, I'm able to combine my like terms, and I'll be bringing down negative 15 plus 4x, which is less than or equal to negative 2x plus 18. And I always want to solve for my variable on the left-hand side of the inequality symbol. So I'm going to be adding 2x to both sides of the inequality, and if you'll permit, I'm going to go ahead and do 2 steps at once. I'm going to add 15 to both sides of the inequality as well. All right, because I'm running out of room here, and I don't want to run out of room. The 15s on the left side will cancel out. My 2x's cancel out on the right side, and I end up with 6x being less than or equal to 33, just like that. From there, we're going to divide both sides by the coefficient in front of the variable, so that's going to be 6. And I end up with x is less than or equal to, both 33 and 6 can be reduced by 3. So let me show that step. So reducing both of these by 3, because we know how many of you love fractions, you'll end up with 11 halves, just like that. So the solution, let me go ahead and put a box around it. The solution here is x is less than or equal to 11 halves, just like that. All right, so you may be wondering how ugly this line graph is going to get, but I just need to remind you that there's no reason to be stressed out about it because I keep things simple. That's right. So here I'm identifying on my number line that I have 11 halves, and if I were to use an open or a closed circle here, I'll be using a closed circle for this first line graph. So I'll be using a closed circle at 11 halves. And notice that my inequality symbol is pointing to the left, so I need to shade to the left for my solution here, just like that. Once again, less than or equal to symbol is going to use a bracket. So I have my bracket pointing to the left, and I'm going to shade to the left as well. So there are two different line graphs that show you how to express your linear inequality. One using open and closed circles, the other one using parentheses and brackets. There you go. So depending on which class you have, you'll know which one to use. There you go. Then, in addition to that, we're going to be getting to those different notations. Let's start out with the interval notation. For interval notation, notice that on our number line here, that we start with the lowest value being negative infinity. So I'll be using parentheses. Remember, infinities, you always use parentheses. So I have negative infinity, and then my largest value is 11 halves. And I will use a bracket because I'm including 11 halves in my solution. So it's negative infinity to 11 halves, and you use your brackets there. That's interval notation. I'm going to put a box around it. There you go. Okay. Then the next thing I want to show you is set builder notation. That's right, the fancy way to write it. So here I'll be using a brace. Oh, that's so ugly. All right, I'll fix it. All right, that's a little better. So I'll have the brace. Then it's going to be x is such that x is less than or equal to 11 halves. Do you hate the 11 as well? Let me fix it then. All right, there we go. All right, that's as good as it's going to get. That's as good as it's going to get. All right, so I know that brace is ugly, but you're just going to have to get over that. There you go. Okay, ask for a refund. There you go. So you have x is such that x is less than or equal to 11 halves, and those are the solutions for problem number 4. All right, there you go. There you go. That was problem number 4. Problem number 4. Problem number 5, we have the following problem. We have a compound inequality. That's right, compound inequality. So here, this is 17 is less than 2x minus 1, which is less than or equal to 25. So what we want to do is we want to isolate the variable in the middle, and for every property that is used, every step that's used, whatever you do to the middle, you have to do to the left and the right as well. So my first step in isolating the variable is going to be to add 1. That's right. So if I have to add 1 to the middle, I'll need to add 1 to the left and the right as well. So notice that we have 3 parts of this compound inequality, and so whatever you do to isolate your variable in the middle must also be done to keep balance to the left and the right. Here, 17 plus 1 gives me 18. This is going to be less than 2x because my 1's cancel out. I'll be bringing down this less than or equal to 26. Then, in order to continue to isolate the variable to 1x, I'll need to divide everything by 2. Dividing everything by 2, ladies and gentlemen, that's what's going down here. So, simplifying this, I end up with x is less than or equal to 13, while at the same time being greater than 9. This is my solution. That's it. That's it. That's my solution. Okay, so the number line situation. Let's check that out. Oh, by the way, ladies and gentlemen, there's another way you can write the solution. Anytime you start out with less than signs, less than signs, whether it's less than or equal to, it doesn't matter, any combination of them, it's going to be an and situation. That's right, an and situation. If you had them going to the right, meaning that you had greater than symbols or greater than or equal to symbols, it would be an or situation. An and situation is an intersection. You're looking for what they have in common. Whereas an or situation would be a union, and that's where you combine the solutions together. So that means that this, if you were to start in the middle and read to the left, you would say that this is x is greater than 9 and x is less than or equal to 13 if you read from the middle to the right. So I read from the middle to the left and ended up with x is greater than 9 because the biggest part of that inequality symbol is facing the variable there. So that's why I know that, notice that it's still the biggest part of the inequality symbol is facing the variable when I flip it around. You'll end up with x is greater than 9 because they're both less thans. You'll have an and situation, and this will be x is less than or equal to 13 here for that second one. So in actuality, this is a shortened version of the following two inequalities with that and in between. That's right. Thus, the name compound inequality, because you're combining more than one inequality together. Yep. All right. So now that I'll go ahead and box this possible solution for you, we'll go ahead and graph it now. So I'm going to end up with these two number lines to show you how to go about graphing this. And I'll need two numbers on these number lines. I sure will. I'll need to show that I have 9 and 13. 9 and 13. Okay. So let me get my ink pen ready. Remember, with this compound inequality, I have x is greater than 9. At the same time, x is less than or equal to 13. So using open and closed circles, I'll have an open circle at 9 and a closed circle at 13. Yeah. And I'll start shading to the right of 9 because it says that my solutions will lie between 9 and 13. So that's why we'll be trapped between these two numbers here as I shade in my solution. So I have an open circle at 9 because of the greater than symbol. I have a closed circle at 13 because of the less than or equal to symbol, and it's going to be trapped in between because it's an intersection of these two solutions. It's what they have in common. Now moving on to parentheses and brackets, I'll need parentheses at 9 and I'll need a bracket at 13, and I'll be trapped in between. So I'll shade in between here. That's right, because once again the solution says that I can find my values that will make the original statement true between 9 and up to 13, including 13, and that's what I'm showing on my line graph here. Let's go ahead and look at two additional ways to represent this solution. Using interval notation, remember you start with the lowest value and go to the highest value. So I'm going to use parentheses 9, 13, and then my bracket. Notice how close these two representations are, that the interval notation is a direct translation of your line graph, especially when you're using parentheses and brackets. So there you go. Got to box that thing up because that's the answer, right? Now I want to show you your set builder notation. So let's get fancy. So I'm going to go ahead and show you this brace that's jacked up, and this is going to be x is such that, and then actually you can just show your compound inequality as we had it before. Yep. All right, and depending on your teacher, you can also just go ahead and throw that version of it right after that vertical bar as well. So either way will work for your set builder notation. We go ahead and box that up. There it is. Yeah, that's what's up. All right, cool. That was problem number 5. That was problem number 5. Let's keep it moving. In problem number 6, we have 14 is greater than or equal to negative 3x plus 2 is greater than negative 7. So once again, we're dealing with a compound inequality. So in isolating your variable x here in the middle, whatever we do to the center, we also have to do to the left and the right. So let's start out by subtracting 2 to each part here. All right. The middle, the left, and the right. 14 minus 2 is going to be 12, which is greater than or equal to negative 3x. Your 2's cancel out, which will be greater than negative 9. From here, we're going to divide everything by negative 3. And remember, anytime you divide by a negative value, not just negative 3, any negative value, even negative 1, you'll need to change the direction of your inequality signs. So I'll bring down a negative 4, which is now less than or equal to x, which is less than 3, and this is the solution to our compound inequality. Notice that these inequality symbols are both facing to the left, so this is an and situation. This is another and situation. So if needed, I could rewrite this as x is greater than or equal to negative 4 and x is less than 3, and this would be my solution here expanded. All right, so if I wanted to expand that compound inequality, I can write it as 2 using the word and. Yep. All right, now let's look at the line graph, shall we? So on these line graphs here, all right, I'm going to go ahead and write them side by side like so. So I'll need -4 and 3 here, and make sure that when you're doing your number lines, you're always writing your numbers in ascending order from the lowest to greatest, even your ticks. Make sure that they're in ascending order to make them correct. Because I have x is greater than or equal to -4, I'll need to use a closed circle here at -4 and an open circle here at +3. Notice that my solutions are going to be greater than or equal to -4, and as they approach 3, I know to stop here because they also have to be less than 3. So that's going to be my solution using closed and open circles. As far as the other line graph is concerned, I'll be using a bracket at -4 and parentheses at 3, and then I'll be shading between those as well. So here I'm shading between these two right here to get my final representation of that linear inequality on a line graph, all right, on a number line. Yep. Just like that, ladies and gentlemen. Continuing on, let's look at that interval notation, shall we? Remember, it's a representation of this version of the line graph. So I will be starting with brackets, -4, comma, 3, close with parentheses. So you always start with the lowest number to the highest number, and you keep those same symbols that you had in your number line there. All right, that's interval notation. Got a red box around it. Okay, set builder notation, we're going to go with the compound inequality version. So it's going to look like this. All right, so I'm going to use my brace. Okay, and it's going to be x is such that -4 is less than or equal to x, which is less than 3, and close brace there. All right, let's put a box around it. If you want to teach me a better way to draw a brace, you go right ahead and send me a message, okay? All right, so that does it for problem number 6, ladies and gentlemen. And once again, this is Mr. Witt with Fort Bend Tutoring. This was solving and graphing linear inequalities on a number line. So I hope you enjoyed it. Please rate, comment, and especially subscribe. We really appreciate that. And in addition to that, if you're able, please donate. That helps us bring you more free videos. All right, take care. Peace.
We certainly hope you enjoyed today's presentation by Fort Bend Tutoring. Did you understand the program? Would you like to rate us or give us some feedback or subscribe to us? You could do all that on tutormemath.net.